All right, in this video we are going to learn how to describe association in scatterplots. So a scatterplot is just whenever you've graphed some two variable data as discrete points and it's not like perfectly lined up. So let's take these two examples here. We're not going to worry about the context for them, but these are both examples of scatterplots. They've got discrete points on a graph. This is not like an exactly linear rule. It's not perfect. It's a little bit messy. We're dealing with statistics here. Now, these two scatterplots are obviously very different. So we need some common vocabulary to describe what's happening in these two scatterplots. So take a minute, think for yourself. How would you describe the difference between these two scatterplots? Right, so the big ideas, there's going to be four things that we need to address here. And they are, whenever you're describing association, you need to describe the form of the association. You need to describe the strength of the association. You need to describe the direction of the association, and you need to address whether there are any outliers. So if we look at those two scatterplots again, ignoring the stuff up here, which one do we think has a stronger association? That was the second thing on our list, was strength. Which one has a stronger association? Hopefully you agree that this guy right here is a strong association because it's close to, it makes a good pattern. It makes a strong pattern. Okay, whereas this one, it's very hard to say that there's any sort of association between these variables. Does age and number of pets correlate? Is there an association here? It sure doesn't look like it to me, right? Like that's very, very scattered. This is a low strength. Whereas this one, time versus height, for whatever this is a very strong association. You can predict the height based on the time with reasonable accuracy, whereas you cannot predict the number of pets with the age with a reasonable accuracy. So let's say that for strength, we're going to describe that as being how closely does the data fit a pattern. Now the form, that is what type of equation would you use to model it if you were to choose to model it. So for right now, we can go ahead and just say, is this linear or not? Now, I don't mean linear as in, like, is it perfect, right? I mean linear as in, is the best model for this going to be a line? Or is the best model for this going to be a curve? Doesn't mean it's going to be a great model, right? It could be a terrible model, but is it better to use a line than a curve? And if something has a very poor association, like the strength is not very good, then you usually stick with a line, because why would you use a curve to model something when there's like, it's not very curvy, right? It's like just a blob. Like lines are the easiest, so if nothing else, if it's not clearly curved, we're going to use a line. So for example, here's one where it's a scatter plot, and it looks to me like it actually has a pretty strong association, but the association is curved, right? It's not a linear association, it's a curved association, a non-linear association, versus the one that we looked at before where it was very, very linear, right? Like that one would be a linear association down below, and this one would probably be linear too, just because it doesn't really look like it's anything else useful. Whereas something like this, right, that's like a moderate association. It's not super strong, but you can tell it's like there's a pattern here, right? Like it's generally going down as the weight goes up, and it would be linear. It's not curved, right? It's, if you were to draw something for it, a line would be better than a curve. So I'm actually going to erase what I wrote before. I want us to say, is a line a better model or a curve? And a line is going to be your default if it's not obviously curved. Okay, now direction. That just is like slope. Is it going up or is it going down? Is the trend up or down? We say that in terms of positive slope or negative slope. Now I use the word slope even though this could be a curve, right, where slope doesn't really exist. And finally, are there any outliers? Are there any points that like there's a pattern and then there's like a random point off to the side? Are there any points that don't fit? Okay, so let's look at some examples. So this page is on 155 in your textbook. You may want to just like flag it to remind you, or copy some of it, or take a picture of it or something, or whatever might work for you. So this is just a description. So like a negative association, right, because it's going down. This is also a negative association, but this one is nonlinear because it has a clear curve. This one is a positive association. They've also added in that it has clusters. I didn't make us write that term down. And then strength is just how well the data would fit a model, right? So a strong association, all the points are really close to the line. Moderate, they're a little bit scattered. This is still pretty good. And then weak would be, it's very hard to tell that there's an association at all. And then here's a good example of an outlier. It has to be really far outside to be an outlier. Like here, none of these are outliers because they're all scattered, right? It has to be something that's like really different from the rest of the data to be an outlier. Like if there were a point way out there, that'd be an outlier. Nothing over here is an outlier though. Okay, I want you to pause and I want you to write one or two sentences describing the association of the weight of a car to its fuel efficiency in miles per gallon according to this scatter plot that you have been given. Make sure to talk about the strength, the direction, the form, and whether or not there are any outliers. Pause and do it now. All right, so I'm going to say that there is a moderate negative. Moderate meaning it's not a great fit with the line, but it is clear that there's a trend here, right? And it's negative because the slope of the line is negative. If this were in y equals mx plus b, the m would be negative. It's going down. Association. I could maybe see that there's a little bit of a curve there. See how up top, like there's more points on the top, and then in the middle they're down below, and then on the bottom they're on the side. So I'm going to say it is roughly linear. I might even say there's possibly a little bit of a curve, but I'm not going to. I'm just going to say it's linear. And we're going to learn later how to like evaluate whether that's correct or not. I'm going to say it's roughly linear, and I don't see any real outliers, right? Because like, yeah, that one's a little bit scattered, and most of the other ones down here are kind of together, but for the most part, it's a pretty scattered graph. So it'd have to be really far out for something to be an outlier. Roughly linear with no outliers. And if I were doing this properly, I probably should have said there is a moderate negative association between weight and miles per gallon. All right. Okay, and here's your practice problem. We're doing the same thing. I just want you to describe the association between the length and mass of, this is supposed to be a gold chain necklace. Describe the association. It should involve at least 1 or 2 sentences. Type that in as your answer to the practice problem, please.